Hi, good evening, everyone. Thank you for coming to this session. In this session, we will discuss in depth about the underlying mechanisms of the blockchain Quorum, which is created by JP Morgan and the Quorum team. And first of all, I just want to thank you for inviting us to this event. And it has been a great pleasure and honor to present to you BlockTEST and Quorum. And, but before we move to Felix to talk about Quorum, please allow us to properly introduce ourselves. Our company is called BlockTEST, and we are a startup company from last year, and it's co-founded by MIT data scientists, the banking executive, and some entrepreneur engineers. And our mission is to provide blockchain solutions to all the business workflow challenges, to help them to solve those challenges using blockchain technologies. That's what we are created for. And right now we are the official Quorum ambassador. We are working with the Quorum core team to provide solutions based on Quorum to our clients, and also help to introduce Quorum to a wider audience. And while we're talking about BlockTEST and our greenhouse tool, feel free to ask questions. But if we have bigger questions, I would suggest that we take that offline, because we want to save enough time for Felix to talk about Quorum. And while he's doing so, you can feel free to ask all the harder questions. So I'm sure everybody in this room is very familiar with blockchain, but outside of this room, lots of people have no idea what blockchain is. This is a joke that always makes me chuckle. The interviewer is trying to hire a blockchain engineer for the company, and he asks, do you actually know what blockchain is? And the person says, no, I don't. And the interviewer says, no, and so am I hired, I guess. So lots of people absolutely have no idea what blockchain is, but still they want to explore if blockchain is the right technology to solve their problem, and that's where we come to help. So, and as we all know that there is no such thing as the blockchain. In fact, there are lots of different variations of blockchains. This is the diagram we got based on our study on ICO data collecting last year. There are 3,600 projects based on Ethereum, and over 50 projects for each of these other blockchain: Quorum, Bitcoin, Waves, Stellar, EOS, and less than 50 projects for 60 other chains that we can find based on public ICO data. So there are lots of blockchains and distributed ledgers. And based on that, we have lots of consensus algorithms those different platforms use. For example, the most popular is proof of stake, and then we have delegated proof of stake, of course, and goes all the way down to the bottom. And for example, the first successful consensus algorithm is Bitcoin, proof of work. And currently the most used consensus is proof of stake. So when we talk to our clients, they always come up with these all kinds of questions. What use case do you want to support? How should we balance performance and security? Who should be allowed to see and who does what? All these kind of questions. They are confused. They need help. And that's why we have, first of all, provide solutions and consultation, and we have built, based on our knowledge, a tool called a greenhouse to help our clients. In its sense, the greenhouse is a DApp development and diagnostic platform. On one hand, it supports interoperability. As you can see, greenhouse, the platform is connected in the figure left. It is connected to a number of chains. Currently, these are the 4 chains that it supports: Ethereum, Quorum, Neo, Hyperledger. And so it provides a unified platform for developing solutions. So you just come to our platform greenhouse, and you can have access to all these different chain environments and deploy the apps and test them. And at the same time, it offers certain metrics, the mechanism to measure the performance and the security. For example, it measures some interesting KPIs, for example, throughput, latencies, and also we do comprehensive security reports based on the static code analysis. So it's like you submit your smart contract, you can deploy that, and we can test that, and it tells you how good that runs and if it has some security flaws. But of course, we can make it better. It's a work in progress. And our evaluation framework, often when a programmer comes to blockchain technology, when he wants to develop a D-app, the environment is the first challenge he has to overcome. What kind of operation system he needs to choose, how much computing processing power, what kind of compilers. And using Greenhouse, we are providing private environments, and you don't have to worry about it. It's only one click away. You can have Ethereum, you can have Quorum, you can have Hyperledger, Neo. It's all yours. We're using the latest standard compiler to compile your source code, and you can choose the number of nodes you want for your testing environment. And as I mentioned, the evaluation framework, people are always concerned about the speed of your smart contract, the speed, the accuracy, latency, and most of all, cost of your the app. And in BlockTEST, we have built-in mechanism to test you automatically your contractors in terms of throughput, how many transactions you can process within seconds, and the failure ratio, does it fail? Is a 100% success? The latency, how long does it take to finish one transaction? And the association fees, the gas, for example, for Ethereum. And for Neo, as the Neo coin. This is just a screenshot of the Greenhouse tool for people to submit their code. Here, it's quite obvious that you can choose one of the 4 chains that we can support. Type your name and give us the URL of a GitHub repository. Hopefully it's public, and hit submit, and then it goes to all the phases. Check your code and deploy that on the respective corresponding chain, and try to invoke it and give back a comprehensive report. So this is just some example. We have, oh yeah.
Sure, so if you go on the previous slide, so you put the URL of your smart contract code.
GitHub, the URL.
That you have to push to GitHub, and then you have, this is kind of like a CI/CD pipeline that runs your contract.
Mm-hmm.
So does this work on your local machine? Or is this like a...
It's a web app.
It's so they run it for you.
So we will fetch your code from your GitHub.
And you're going to run it locally.
On our server in cloud.
And execute.
Yeah, exactly. Right. And this is just an example we have run using we run the same smart contract on 2 different chains. So on the left-hand side, that's Ethereum. On the right-hand side is Quorum. And we compare the throughput, latency. We can see in this case, particular case, Quorum is much faster than Ethereum, way orders of magnitude faster. But that doesn't necessarily mean that Quorum is better or Ethereum is worse. It just shows the goal of this is to show more parameters about this smart contract, the app that has been developed to give the user more information to evaluate which chain is more suitable. And some very high-level overview of the architecture. On the ground layer, we have the metric measure, data warehouse, vulnerability checker, a synthesizer, and of course, the chain environments. The blockchain engines create the environments for deployment testing. And on the second layer, we have this mechanism for testing performance, security, scalability, and cost. And then on the third layer, that's some apps for users to play with. For example, we have a marketplace of user publish the apps. They can see the metric measure, and they can share the results, send email to friends. And they have these challenges that they can attend to. These challenges are the use cases we have collected from our clients, and so we challenge our users to go for them and build their own apps. And if we just zoom into the layer 2 to look into our testing environment and the metrics, these is the, I think that's a 4-dimension. It's a nice job we have drawn 4-dimension on a 2-dimension slide. On 1 dimension, it measures the resource consumption, CPU, RAM, transaction fee, And these dimensions, we measure technical performance, transaction failure ratio, throughput, latency, and the workload, and we can adjust the network size and the workload level to test its elasticity and its scalability. And on this dimension, the solution robustness, we check its security, check the chain security. That's all the key measures we have. And that's about it. Thank you. And any questions? Yeah.
So when you say you compare the smart contract across multiple platforms,
Yeah.
for example, if it's on Ethereum, then is it the public chain or is it a private deployment?
No, we want to have a apple-to-apple comparison. So if we spin a Quorum with 6 nodes, then we spin a Ethereum with 6 nodes with the exact same resources, computing power, RAM, exact same thing, and exact workloads, and test them. That's all tested in the exact same environment settings.
And a follow-up question, do you spin up all the nodes like especially for each contract, or it's like already running Ethereum network and Quorum network? And,
Yeah, it's already running. Well, we can do both, but every time if there's a test, we spin off a new network, they'll incur a lot of unnecessary costs. So it's one test net for Ethereum, one test net for Quorum. Yeah. Okay, so coming up next is private mechanism of permissioned blockchains, a deep dive into Quorum. And there you go, Felix, it's all yours. Oh, and I'll give you the screen.
Yes.
It's all yours.
All right, so hi everybody. We're gonna talk about privacy mechanisms of permission blockchains. We're gonna use Quorum here, but this is actually applicable to many different blockchain implementations. So if you have questions, just ask. I know my English is a little iffy, so again, if you don't understand something, just raise your hand and I'll repeat whatever I was saying. And welcome. So thanks for the wonderful ambassadors we have here. So Quorum is a product of JP Morgan, and I'll go into some details in a minute. Before that, I'll explain who I am. So I worked in a bunch of startups before. Actually, I worked with David Cancel, who's out of Boston. We worked on a product called Ghost Trade that was a little while ago. And I started in JP Morgan about, I made a little mistake. 2014 is when I started, so the years here is all screwed up. But I've been working for JP Morgan for last 5 years, and it's a very big place. It's very exciting. There are some really cool cutting-edge projects, Quorum being one of them, but it's not the only one. There's a lot of jobs and a lot of interesting projects and a lot of interesting work being done in JP Morgan. So if you're looking to switch, you should totally check out our careers. We're always hiring. But last year and this year, I've been working specifically on Quorum Core. Quorum Core is really software that defines Quorum. So Quorum itself is, we'll get to it in a second. So I'm a tech lead, and I also lead developer advocacy for Quorum team in JP Morgan. So we're gonna cover only a few things here. First, I will go in detail what is Quorum, and then I'll go into the privacy implementation in depth, and then we'll have some kind of Q&A for us. So, for those who don't know, Quorum is a fork of Go Ethereum client. It's an open source fork. Go Ethereum licensing is LGPL 3 for parts of it, and GPL itself for some other parts of it. So all of the work that JP Morgan does with Go Ethereum fork is open sourced, and it's called Quorum. The actual fork itself came from when we developed it. We worked with with Go Ethereum or Ethereum core engineers, Jeff Wilkes and his team. He's actually the chief engineer behind Go Ethereum or guest client for Ethereum. So our fork, Quorum fork, is really designed around developing blockchains or setting up blockchains for private environments, and the features that we added into Go Ethereum are specifically for that. And it's the features are designed for privacy, speed, throughput, and finality. And we call it permission group of known participants. You can actually set up quasi public frameworks, quasi-public blockchains, but you have to know the differences of what happens here. So the key features is that we have confidentiality, we add security, and it's still a decentralized blockchain. We're also trying to create or piggyback on the existing community of Ethereum ecosystem. So any project you can think of that works on Ethereum will work out of the box on Quorum. We don't want developers to relearn things like new language or anything of that sort. So if you know Ethereum right now, you already know what Quorum does and how to operate it. If you ever written a dApp for Ethereum, it's directly applicable to how Quorum operates, and so your dApp could be deployed on Quorum without any changes, and it should operate the same way that it would on the testnet or public mainnet, except it would be a lot faster, and you wouldn't pay actual money to execute the transactions. Okay, so the key features are, these are the 4 pillars of what Quorum changed in Go Ethereum. So the privacy, so we have Quorum adds ability to have private contracts and private transactions. We also have a zero knowledge layer right on the blockchain, so it's a little light, and I'll cover it later on, but we have this ability now. In terms of performance, we offer what's called a pluggable consensus mechanism, so you can pick from one of the 3 consensus mechanisms we ship with, and if you're so inclined, you can write your own consensus mechanism. So we have one consensus mechanism called Raft, and it's specifically designed for sub-second block time. So it does the blocks every 50. It mints blocks every 50 milliseconds. So it could have a very high block propagation rate. So your transactions could get to all other nodes really quickly. And we also have a Byzantine tolerant algorithm called Istanbul. So Istanbul is a little slower. You can configure it to be 1 second block time, 5 seconds. It's configurable versus what public Ethereum is. But once you configure it, that's the speed that it will operate in mint blocks at. And the big difference between Raft and Istanbul is that Raft is a leader-follower type of mechanism and creates its own network specifically for Raft. And Istanbul is a more plain vanilla P2P protocol, and but it's a BFT tolerant protocol versus what Raft is. In terms of finality, so one of the big things in enterprises is that we don't want to fork and have different result output depending on which side of the fork you are. So Quorum actually prevents this. So you have finality on transaction level, so transactions cannot be reversed once they're accepted by your chain, by your node, and there is no forking. And then finally, we have permissioning. The permissioning subsystem is still being developed and being worked on. The lowest level of it is it's a whitelist of all other nodes you want your particular node to connect to. So what it allows you to do is set up a blockchain where you know every participating node, and you can pre-configure it before you start up your chain. So the high-level design is as displayed. So you have in yellow you have Quorum blockchain. That's n number of your nodes that make up a blockchain. On top of it, you have dApps that talk to a Quorum blockchain. Specifically, they would talk to any particular node. A node in Quorum is actually 2 pieces. You have a modified Go Ethereum, which we call Quorum node, and we have a private transaction manager, which is either Constellation or Tessera. I'll be talking about Tessera here, but Constellation behaves the same way. There are some differences. I'll cover them later on. And so both of these are seamless. So on your dApp, you actually very rarely, if ever, need to know what the transaction manager or where it's at. You will always talk to the JSON RPC endpoints of your Quorum node, which is exactly what your Ethereum node would be. And on the bottom is just a list of public tools that work out of the box with Quorum. So this is a little weird. Sorry. So Truffle works, MetaMask works, OpenZeppel, and Remix. Really, any tool that you use with Ethereum will work with Quorum out of the box. The only difference is you reconfigure the connectivity service to wherever you set up your node for Quorum.
How does Truffle interact with the privacy, the private transactions? Because presumably they're a pipe to Truffle, right?
Right. So Truffle is it's a piece of software that's written around Web3.js, which is kind of like a fancy wrapper to allow you to automate the deployment and configuration of your smart contract over a particular node. So they have added support for sending private transactions, but to be fair, sending private transactions in Quorum is exactly the same API and almost exactly the same signature as it would be on the regular Ethereum. So you would use Web3 ETH.send transaction. The only thing is we added one variable in there, which is called private4, and I'll cover this in 1 minute. So Truffle, so Web3 is actually patched to support this. So when you use it with Quorum, if you add private4, it would get passed to Quorum and it would know that it works. We also have Quorum.js that actually automatically patches your Web3 provider if you pass a Web3 provider to the library. But Truffle, as I said, builds in support for Quorum, and it's just there. So using Truffle, you define a type of blockchain you work with, which is called Quorum, and that's that. It will just pass these transactions, and it will work. And if some of the transactions happen to be private, so they're private. In fact, the previous Meetup kind of covered an example of this. I don't want to go into details of this, but afterwards, if you talk to me, I'll give you the presentation and you can see and walk through the stuff, how it works. Okay, so that's the high-level design. There is not much detail into go into Quorum. I think one more big thing is that Go Ethereum has releases quite often. Quorum is not up to the latest release of Go Ethereum, but we actively monitor Go Ethereum upstream changes, and on regular basis we pull them into our main repository to ensure that our client, Quorum node modified client, contains most of the bug fixes and any other issues that affect the public chain, any EVM changes and anything of the sort. I think right now we're at guess 1.8.18, so we're pretty close to the main public releases. Right, so actual implementation of the in-depth implementation of privacy in Quorum is actually quite simple. It's quite unique because there's other implementations that haven't done this, and it still follows a decentralized privacy model because your privacy model is still based per node. So you don't have it remains decentralized. There's no dependency. There's no central node. What happens is when you set up the transaction managers, they kind of create their own network. So if any of the nodes go down, the network still operates. So it's separate from Quorum in the sense that it's a completely different network. There's no particular dependency on any external applications, so you don't need that for app to ensure privacy. We also support ZKP and any other on-chain things. So the zero knowledge stuff, actually I'll go into the detail later, but we also follow single chain architecture. So there's lots of ideas of side chains or multi-chain implementations that kind of allow you to do privacy. So your multi-chain could be different between different parties. So in Quorum we eschew all of the stuff. It remains a single chain architecture. The only big difference is that we split the state into public and private state. So that's the only big difference. And here's the details of how this is implemented. So on the Ethereum level, when you create the transactions, your V value will be 27 or 28, or it will also depend on your signer. So it will be a multiplication of 27 to 28 times chain ID. So we patched this. We added one more v value, which is two more v values, which is 37, 38. So what happens is when a transaction with this v value is encountered by EVM, it will know that, okay, this is a private transaction, so first I need to fetch its payload. So the first point here is that we split the state tree and the state database in every chain into public and private trees. They're separate. We ensure that as the last point over here is that we ensure that whatever is in public state cannot override private. So you can't, if you have a layman source, if you have a public smart contract, it cannot access or call on private contract. So public cannot call on private. Private contracts can call and read values from public state, but they cannot modify them. So that's the last point where we prevent this. We have an EVM layer thing that prevents this. Then finally, we added one more thing that into some transactions that identifies which transactions are private, and then also provides who was a intended recipients of this transaction. So those are modifications of the Ethereum node level, and then finally, along with we have what we call is a private transaction manager, and that's in our case we're going to talk about Tessera, but there's quite a few other open source implementations. There's actually three others that I can say. They're similar, but they all offer different. Some of the features are different. So Tessera is JP Morgan's implemented private transaction manager. That's what we call an enterprise transaction manager. It's been implemented in Java. The reason why we did this in Java is because Java is well supported in big and small companies. It's well understood and has a big ecosystem. The other big benefit is that if you're in a big company, Java gives you a bunch of layers that allow you to plug into enterprise level things that you would have, from your HSMs to a database to some kind of login services, stuff like this. But we also ship everything that's needed in the Tessera itself, so if you don't have any enterprise services, it will still work. Okay, so this is how it works. So ignore this for a second. This is actual code. So whenever you write a transaction in regular Ethereum, you will just write my contract new, some initial parameters from Ethereum account, and then you would have bytecode in your data field. You would not have two. In the private transactions, the only difference is that we add a new parameter called private for. There's actually two parameters. One is called private from, and but if you don't specify it, it's assumed that whatever the originating node is going to be party to this transaction. So that's what the actual would look like in your Solidity or your guest console or whatever other tool you use to write private code. This is actually a light display of how it works, but there's actually a more detailed diagram in just a little bit. So Tessera and so itself, Tessera uses a NACL or Salt crypto library. That's the one. The actual payload encryption and authentication uses XL20 encryption. I think that's a symmetric encryption. So these are the features that we're implementing, and finally there is a hashing that's used in SHA-3, and you'll see why hashing is used in a little bit. So Tessera right now generates key pairs and holds the private keys locally, and we use Argon2 to actually protect the stuff. What's up?
I was just going to say, is there any reason you went with Salsa instead of Chacha?
No, but I don't have an exact answer off the top of my head, but the beauty of this thing is that it's open source, so you can change a few lines of the enclave code, and you will have your own encryption. But I don't really have exact answers for why one was picked over the other one. At least not off the top of my head. I could go back to the team and figure out why exactly we picked it. We did pick some of the stuff We didn't want any NSA curves or anything that was U.S. government related, so others could ensure that it's truly developed in open source manner. But all the stuff is replaceable, meaning that you can actually patch your own tester with whatever you want. Plus, the code itself is open source, so you can take a look how we implement this. So there's one thing that I don't mention. The tester itself is also intended to be, private transaction manager also intended to be two separate pieces of software. So we have the transaction manager, so that's the thing that ensures connectivity to all other transaction managers. And then we're supposed to have enclave. Enclave is a piece of software that's intended to do only encryption, decryption of your private payloads. And the reason why it's supposed to be set up because some of the enterprises can offload this to your HSM, so your things like HashiCorp vaults and other implementations. We fully expect this to be plug-and-play type of deal at some point in the future. So right now, specifically in tester implementation, we already split it up, but it's not quite ready to be plug-and-play or replaceable yet. But this is where the architecture we're going for. So this is actually the transaction anatomy. So I'm gonna walk through what happens when a private transaction happens, and so this is explained, so you can read it, but I'll walk through it verbally. Go ahead.
Correct. I don't get the role of the transaction manager. You want to explain that?
Sure. So the reason being is that the blockchain, specifically Ethereum, is developed for when you set all it does, the dev P2P layer, the networking layer, is specifically designed to transfer transactions and blocks, nothing else. Right. So those are the two basic layers. So we needed another layer to transfer private payloads, point to point. So dev P2P layer specifically designed P2P, so not everybody has to be interconnected. So let's say I'm a node, I only have a node over here and over here, so I pass the blocks only to these two. And they also pass it completely different manner. Transaction manager is designed to be direct. So basically, you have to know the recipient, and as a private payload, the secret thing is only transferred between the participants, and never is written or never hits the public blockchain. So for that, you need a separate piece of software with a separate networking layer. Sometimes we refer to it as a shadow networking layer, and that's a separate networking layer specifically for privacy, and that's the transaction manager. So it's a server that handles this type of connectivity between all of the participants of a particular private transaction.
And eventually later on, the transaction that happened between closed nodes would be propagated to the other nodes as well.
No. So
It will stay within these nodes?
yes. And again, I think it will become clear as I walk, because this is specifically designed to explain, okay, what exactly happens when I send a private transaction. So there are three participants. So you have A, B, and C. Each one runs a node, and each one runs a transaction manager tester in our case. So each one has a separate one. In terms of networking, this would definitely almost always sit on the same server or the same machine, and you usually collocate Quorum node and a transaction manager. It's not required, but that's what usually happens. So you have three participants. So the participant A, you have a distributed app that's originated or created a private transaction. So that's the step one. To do this, it will use JSON RPC Web3 method send transaction, which will call an JSON RPC send transaction method on this node. But it would pass as regular things that you pass in regular Ethereum. So from to guess and then either value or data. So if you pass value, you can do a private transaction. So Quorum specifically does not use Ether or gas inside our blockchains, and so you can't use the default token as a private token. So you would basically only use private transactions for smart contracts. So you originate a private transaction for a smart contract. The only difference between a regular send transaction is that you would have a private for, and your private for would be to participant B, and it would not have participant C. So that's the first thing. Your node receives it. It takes the transaction payload, which happens to be the data parameter of your transaction, and sends this transaction sends this payload to the transaction manager and says, this payload is destined to party B. We engage a connection. First, we actually take the data payload. We go to our enclave and we encrypt it. The symmetric keys that came from this manager, from this node, because it's a participant. It returns the symmetric payload, or the hashed. Sorry, it will return encrypted payload over here. The hash will be eventually, it will go back, but before it goes back, transaction manager ensures that this private payload is passed to tester node B, so the participant B. So now, before anything else happens here, the transaction and payload is now written to is now passed to the participant B. So from here, it gets confirmation and acknowledgement from node B. It says, great, we're going back to our Quorum node, but instead of passing payload, it will now just pass the hash of this payload. So SHA-3 signature of the encrypted thing. So we never pass all of the encrypted stuff remains over here. And here we just pass back the hash, and hash replaces the transactions data over here. So the data is now destroyed. We actually get rid of it. We replace it with a hash. We change the v value to B37 or 38, depending on what type of transaction it was. And at some point, this transaction is propagated to the rest of the nodes. One of these nodes mints this transaction into the block. The block is then distributed to the rest of the nodes. At some point, this block is received by node B, which is a participant. Go ahead.
Can C mint the block?
I'm sorry?
Can C mint the block?
Yes, absolutely. So because when the transactions that it tries over here is no longer, it will be public, but its payload will be a hash.
How does C validate the hash?
It doesn't. So what happens is, we'll get to this, but basically, let's say if it's minting a block, it will encounter a transaction. The transaction happens to be private. It will just say, I don't know what's the payload of it, but we allow all private transactions because it was written by somebody participating on the blockchain.
So, so you're trusting that the enclave, is there some kind of remote attestation of the enclave output by C, or?
No, the C never, so C, because it was never a participant, would not know who were the participants at all. In here, if it happens to receive a block is a private transaction, what it would do is this. It would say, okay, I received transaction 1, 2, 3. And I see that it's private, but all I see is a hash. I know 1, so that it's private, 2, hash. So we'll take this hash and talk to my transaction manager and say, was I party to this? Do you have the payload? And if you are the party to it, the payload is received, and the private state is updated over here. But when you're not party to it, it's not received, because we never found this transaction, we were never participant to it. And C will just skip this. It's a no-op transaction.
What's the value of having an unvalidated opaque hash on a blockchain?
There's several things, but there's basically something that could be, the idea is that it's a private signature that it happened, and so if you later on, it's a proof that this transaction happened between A and B, but only at this point, only A and B knows that it happened.
So it's for auditing?
Auditing would be one reason, but let's say there's a trust issue and you need party C to take a look at that and validate that it happened. Because it was written on the public blockchain, they trust the fact that it was executed by the transaction managers, and they could have keys from these transaction managers to verify what were the actual payloads, to compare, to ensure that the hash the hash that was written was the payload that they said it was.
So is there automation for that, or is
Yes.
Okay.
We have tools to automate the stuff. Right?
And if node A and B are destroyed without backup, then you lose the private transaction.
So it's very similar. It's very similar to what happens to your wallet. If you happen to lose your key, it's gone.
Yeah.
That's it.
But if
Because this is enterprise software, we tell you exactly how to ensure what things you need to back up. So in case you need to disaster recover any particular node, you need the node key for the particular node plus keys that your transaction manager was responsible for. What happens then is that the rest of the blockchain is at block 1 million, and your your node just starts up from block 0. As the node fetches your missing blocks, the transaction manager in the meantime is asking all other transaction managers, was I party to any other transactions from you before? And because let's say this was the one that's being disaster recovered, it will ask A and C about any transactions that it was party to, and A would know that we spoke to B at least once because there was a private transaction, and it would pass the payload. And again, as your blocks are catching up over here, it will at some point encounters a private transaction, ask your transaction manager, and because you're being disaster recovered, it will recover the state over here.
Are private transactions free? Or do you have to be...
So that's a very good question that I didn't speak about this, but really briefly, the answer is yes, that's one. Two, so Quorum blockchain is specifically designed, we patched Go Ethereum to be gasless. Basically, gas price is always set at 0. And so what that means is that most of the transactions are free. Private transactions are specifically free because we don't want to leak things like, okay, how much gas a particular transaction used up. So this is completely refunded to what originated in the Ethereum account.
So so anyone can send a private transaction on the network, and the other nodes will just propagate it because they aren't able to validate what's inside the transaction.
So the validation actually happens over here. So whether it's public or private, first thing that it actually does, it goes into validate transaction method on your node's end. So if it fails for some reason, like you didn't supply enough gas, it will actually kick back and say you didn't supply enough gas if there's any other validation failures. But yes, if this passes and everything else was proper, the transaction is written and it goes across the network. So your question leads to like, okay, how are network attacks prevented in public Ethereum? The way that it's done is that gas is linked to price of Ether, and every transaction costs you actual money. Quorum implementations are not designed to be public. You can run a public quasi-network blockchain, but this piece of software is specifically for private blockchains. And in private blockchains, you actually will know who it's not participant A or participant B. This would be Felix, and this would be John, and this would be Alice. You would know these people. So if somebody is being noted, you can actually kick them off or call the people responsible and figure out what's happening, right? So the idea here is that it's not a fully public hostile network.
Alright, I guess I haven't looked at the GET code for a couple of years, but I guess like 2 years ago there was no code in there to try and give a reputation score to your peers and kick them off the network if they send you like false transactions. So did you add something like that?
That's right. So this has to do with what we added, right? So if we go back to things that we added, that's permissioning, right? So when I said it's a whitelist, you can remove somebody from whitelist, and that node is no longer part of your blockchain, and it can't send transactions or receive transactions from you. Done. So Quorum has this feature built in. So you basically may configure it, and that's how it's going to operate.
Is this deployed in production for transactions of real value?
I'm sorry, what was is it deployed production or what?
Keeping track of transactions of real value, like monetary or some other kind of transaction?
Okay, so yes. So Quorum, so you have to remember that Quorum itself is it's a building block, it's a blockchain. So the value is on by building the actual applications or distributed applications on top. There are, we're aware of more than one company running Quorum in production for Block, for whatever use case may be. JP Morgan itself is running it for more than one use case and making money on top of it. So yes, it's definitely been used in production.
And with these private transactions?
Yes.
Are you speaking of JPM Coin?
JPM Coin uses Quorum, but that's not a production thing yet. But for example, JP Morgan has an interbank information network, which is a production application used by many banks. Each one runs their own node, and the actual use case inside is that they speak privately, between the banks speak privately or send private transactions. But there are many more, and others have announced things that they're building on Quorum, and there are big lists of things like that.
I have a question around step 5 in that diagram. So you said validation happens at participant A only, or I think participant B is also part of that validation, right?
So which validation are you talking about?
Validation of that the transaction is possible. For example, A has the resources, or like whatever the smart
So
contract is.
consensus on what was executed as a transaction. So there are a couple of issues in here. So the consensus, what we spoke about, that Quorum node C that was not participant to this can mint a block with this transaction. So what happens is there is no consensus right now on private state. We do write hash to validate that these two nodes agreed that this was a state, but there's no consensus or verification of that. So for that we have several issues. I mean, this is one of the issues in Quorum that we're actually closing up this year. We will implement a private consensus, so where validation of whatever both nodes agree to this and also write the agreement as well on the blockchain. But however, right now it's not done. What you can do is, right this moment, you can actually validate or compare hashes of the smart contract, the private smart contracts. So this is out of sync operation. You would run it whenever you want to. You would call a new JSON RPC API via the specific for this on node B and node A, and then you would compare them. And if for some reason they're out of sync, then something went wrong. But if they are still in sync, then there is a consensus. However, as I said, it's out of band operation, so you do this on demand, maybe once a minute, once an hour, what have you, and that's how you compare it. But we have this is a very high priority feature that we're actually finishing up this year. Shouldn't even say this year, likely by the end of this month or next month. But
you said that one of the things that you're doing this specific example, being you're getting the agreement of the two parties, private transaction, multiple parties, private transaction, to agree that the transaction was legitimate, and then putting that in some sort of consensus system. How are you ensuring the privacy of the recipients of the transaction at that point? Because without that consensus, I don't know necessarily. I know who deployed the smart contract, but I don't necessarily know who the recipients are.
So you have to keep track of this out of band, right? So the modifications to the Quorum node are specifically designed that your deck over here needs to be smart enough to know that, okay, I'm communicating over a particular smart contract, and the recipients of it are A, B, and C. And for smart contract 2, I need to know that it was supposed to be just A and B, and smart contract 3 would be just B and C. So you have to keep it and monitor it yourself. We don't give you tools for this, but once you have a way to do this yourself, then whenever you say B and C, it will always remain B and C. Meaning that you don't say, I want to talk to participant C. You would have their public key. The public key doesn't change, and you use that.
Yeah, I was speaking more towards when you eventually migrate to the point where that the validation between those private parties that it was a legitimate transaction gets posted to the public chain. That they are all confirmed as a legitimate transaction. How are you keeping privacy for those recipients if they are validating the transaction? The consensus eventually for the private transaction goes back to the public.
So this is actual details. That's the meat and potatoes of how the private consensus will work. I'm not 100% sure how it's going to work right now, other than it will just work. Now, I know this sounds like magic, but I can actually supply the details. I'm just not on the teams that's doing this.
Right.
But I do know it's very high priority, and we have a solution that's already in place that we're prototyping and, sorry, not even prototyping, implemented and working with. And if you message me on Slack, I'll try to provide some details of how we're planning to do this.
Sure. Thank you.
Go ahead.
Can you tell us an overview of differences comparing the three, Quorum, Hyperledger, and R2 Corda?
So I don't have it anywhere here, but they work completely different. I mean, they all support similar features in the sense that each one will have privacy, each one has some kind of permissioning. They all accomplish it different ways. So in Hyperledger, it actually also depends which project you're talking about, because there's quite a few.
If Hyperledger is optimizing for more like public voting and stuff, and R3 Corda is optimizing for more finances.
Yeah, but that's, Corda is financial, but Ethereum itself is just a smart contract-based thing that's supposed to be Turing complete language, meaning you can write any code that will execute. Quorum is the same way. So you can use it as simple data storage or database. Your smart contracts will just store values in rows, or it could be use cases specific to whatever it is that you're trying to do, maybe proxy voting, anonymous voting, bidding, whatever, right? So even CryptoKitties, there's no reason why you couldn't run it on Quorum. But we don't specify those use cases. You, as a user, have to kind of identify what fits. So the basic question is like, what use cases are better to do Quorum versus on Fabric versus on Corda? I actually don't have a good answer for this off the top of my head. I know that Corda is specifically for financial use cases, but that's really all I know about Corda actually. Because Fabric is really open-ended, so it's a more generic implementation. But I think I mentioned this before, it's a big difference between Quorum and Fabric is that Quorum is a fork of Ethereum. So if you learn Ethereum once, you know Quorum. Fabric, it's a great system and it's pretty stable, but you have to learn everything from scratch. So the concept of blockchain, as you know, as it applied on Bitcoin or Ethereum is completely different on how they mean to run this on Fabric. And Fabric is just one flavor of what Hyperledger offers. There's a bunch of other projects in there, so you kind of have to pick which one and understand how they work, and they're all a little bit different. So we're targeting people who understand how Ethereum works and want to run Ethereum applications, but in a private setting. So that's the whole idea of private blockchains. And I think the big difference from my point of view and our development point of view is that Ethereum is now well understood. It's a well-known and well-trusted public blockchain. And we're piggybacking on everything that we do, and hopefully we're also committing some of the work back so it's useful. So, if you learn Ethereum in your own setting, you can now find corporate jobs that could use Quorum, but you will use the same things that you learned already for Ethereum. It will just work. So that's the idea of how Quorum is different from Corda or Hyperledger projects.
If you're using symmetric encryption and transferring the encrypted payload and the key through that step 5, then why are you even encrypting the data?
We don't ever transfer key. So it's signed with right. So going back to here, right. So this is the encryption, and that's the authentication for payload. So you never your private key never always stays in your transaction manager. It never goes out. Your public key does. Using public key, we can do symmetric encryption.
So it's asymmetric encryption.
Yes. So I didn't finish this, but the basic idea is, as I was saying, once the block is received, once the transaction is sent, these two will have payloads. This one will not have payload. So your Quorum node will receive the transaction at some point as part of any given block. So node C will receive a transaction, will unpack the transaction, read it, see that it's private, talk to its transaction manager, figure out that we don't have payload, it will just skip it. This node will talk to your own transaction manager and receive the payload. The payload goes back in here and replaces this transaction. This is executed in EVM, but it goes into private state. So both of these private states are now up to date, and then it just continues. That's it. That's the whole implementation of what we have in Quorum. So there are some interesting points here. So actually the tester itself is it's a transaction manager are pretty lightweight. So you can actually run transaction managers without running Quorum nodes to create your own private net. You can actually, it's quite similar to how Signal works. And Signal runs the servers on your behalf, but you can actually set it up yourself, and you can use this for like PGP for email if you want, or for anything you want. But we actually created the bridge for Quorum. But it's open source software, so you can use it in any context you need to create privacy, where you transfer pretty specific payloads. But these payloads could be anything. So the tester itself doesn't care what the payload is, right? So it did not have to be the bytecode from Quorum. You could have replaced this with some other software. It would be kind of cool to see implementations like this, but they currently don't exist. But that's to say that it's possible to run it like that. So tester and transaction manager provide one type of privacy, and they provide P2P privacy. But we also have on-chain privacy too, with a ZSL use case that we did with Zcash company 2 years ago. So there are some caveats. So what we built 2 years ago is a POC. So we don't, we tell people to build on top of this, but don't go into production with this. Reason being because it's non-standard. It really implements just one particular use case, which is ERC20 tokens. It could be, you can mint as many as you like, and they could be shielded right on the Ethereum blockchain. But it's a single use case, and that's not what we wanted. But it is there. It's available. It works. We support this, but we will actually have a production level ZSL quality support sometime this year. I can't commit to timeline because I don't know exactly when we're doing this, but we have an implementation coming as well. It will support some other use cases as well, but ERC20 is the important one. That's the use case where you shield X amount of particular tokens, and you can use mass to ensure that everybody has the values that they're claiming they have right on the chain. So there's a very limited ZSL support right now on public Ethereum, mainly because doing ZSL type of stuff takes a lot of gas and it's a lot of mass. So the block size is small on comparatively small on public Ethereum, but in Quorum you actually control the block size, and we started with 4 billion gas, which is enough to run ZSL transactions as well. And I think that's it. That's all I had for privacy. So if you have questions, ask.
Does the private transactions component, like with the transaction manager, work with the public Ethereum network? I use it to route my messages to someone else?
It's a great question, and the very short answer is no. It's not impossible to make it compatible, and we're likely to run some Gitcoin and some other bounty programs where we want people to kind of take a crack at implementing this. But the very short answer right now is no. Reason being is because when we modified Go Ethereum, we ripped out things that we don't need, including proof of work. And so you can't use our client to connect to mainnet, right? So it will just fail because we don't have the networking and the consensus mechanism to do proof of work. But you could actually just externalize the privacy part and run a client in public that kind of does this. Now there will be other issues, right? So in any case, Short answer is no, not right now, but it would be an interesting project for somebody.
Is there a concept of private smart contracts also?
Right, so when we say private state, we actually mean it's all private smart contracts. So whenever you create a smart contract on Ethereum, is still originated by a send transaction with data, and you only have from, but you don't have to. So this tells you know that you need EVM create. You run an EVM create, and this will create a smart contract. And so if you added private for, then it will become a private smart contract between the recipients.
So how do you scale the enclave or HSM separately? I guess you said you can detach them?
Not right now, but you will at some point.
At some point, so now you have to so
now
you
just
limit-
part of Tessera itself. It's
So it's
implemented.
now
in
just
it.
software based. Eventually, it's going to be hardware based.
Yes.
But you're still going to be limited by the amount of hardware. It's going to be expensive to run it through it.
Yeah. Don't quite have the answer to that, other than we want to support hardware solutions, but throughput and stuff like this, I don't know right now. We'll see when we actually start implementing the stuff.
Do you have an idea how big of a node network you've run Quorum on?
So we haven't tested full
What's
capacities, but with Raft requires connectivity between each node versus Istanbul, which doesn't. You can set up Circle or whatever type of networks you want, and it has less requirements. So with Raft, we tested between 500 and 1,000 nodes, and it operated just fine. With Istanbul, you have no restriction. It could be as big as you want to be. We heard of use cases where it was thousands of nodes. But I haven't personally seen this, but there's no reason why it wouldn't. We have so we've written a layer which does acceptance tests for us when the thing that checks our own code. Our next step is actually to create a few tests that do scaling and like really try to set up or simulate a really big blockchain setup with Quorum. Again, off the top of my head, we haven't done this. With Raft specifically, we tested it up to 500 to 1,000 nodes. It will probably struggle going higher because it's a leader-follower model. So if the leader has to keep track of more than 1,000 nodes, it's going to be slowing down. But Istanbul, again, doesn't have any of these issues, so you can use as big. Your network could grow as big as it needs to be. In terms of performance, specifically for private transactions, it will grow as with a number of recipients. So every recipient will add overhead because you have to. Right. So when you create a private fork with one recipient, you only went to one recipient. But if your recipient was 1,000, your node will have to go and make 1,000 calls to speak with each transaction manager. So as this scaling is actually quite poor. So we have some other work that we're doing where we'll do this in parallel, blah, blah, blah. There's a bunch of things that we're doing to accelerate this. But in terms of actually getting your own performance metrics, you would need to kind of set it up and run or emulate what you're doing. The reason being is because transaction speed depends on how many recipients there is, plus how big the payload is. So that means how big your smart contract is, or what's the average size of your smart contract transaction. So if it's high, or if you send in a lot of data, you will have one metric in terms of performance. But if you're sending much smaller payloads, again, you will have much higher throughput and much higher speed. So it really depends on your use case. So you have to measure it yourself when you're setting it up. Or you can use something like BlockTEST greenhousing.
At some point, even JVM will give up, like if you scale to many number of nodes.
We haven't encountered this, but it's Java. You can throw as much memory as you want to it, but yes, there's definitely, you can run out of resources if you create a network big enough. Definitely.
What's the criteria for adding a new node to Istanbul?
So So again, this is something I didn't cover over here. So we have two consensus mechanisms. We have Raft and Istanbul. We also support Click proof of authority, which ships with Go Ethereum. But the big difference is in Raft, every node, any node can become a leader. That's the node that will mint. It's really a networking performance, how it relates in the rest of the net. So the fastest node usually will become the leader. That's Raft. In Istanbul, it's you have two types of nodes: regular nodes, which basically just participate in the blockchain, and validator nodes. So the difference in them is that validator nodes are the nodes that are responsible for building, creating new blocks. So the metric is you have, when you set up your blockchain, you need to figure out what your tolerance for faulty nodes is. And there's a formula that we provide you, which is 3n minus 1 is how you set up how many nodes you need in the network. So minimum is for Raft and Istanbul, you can run a single node if you're just running in testing. But for production stuff in Istanbul, you should go with 5 or 7 nodes to tolerate one node failure. And in Raft, it should be 3 and up, however many you have.
So then for Istanbul, any node that joins network can become a master as well? Or?
No, that's configurable, right? So we give you another JSON RPC API, and when the node joins, you can join it as a regular node, in which case it will not mint any blocks ever. It will not be a validator. There's an additional API on top of it that says, okay, make any particular node according to its enode ID. I'll say enode ID, but it's actually not that. There is a enode ID plus Ethereum account that maps to create a particular node, but you can make any particular node a validator. So it's actually a voting mechanism. So let's say you have 5 validators right now. 3 validators will have to confirm that they're adding this as a new validators, and you will now have 6 validators.
That's the same mechanism as Click, right?
So exactly the same. Exactly. Yep. So Click and Istanbul are very similar, but the difference is how the seal and voting mechanism works. How you vote on a particular block.
So at the end, there's not much control with the initiator of the blockchain, right? Like all the configurations are done once, and then there's no.
Yeah, the idea is that you don't have to restart the blockchain every time you do any change. So you join and remove nodes and add nodes to a live environment, just like it is in regular Ethereum or Bitcoin.
Also, a follow-up question is about data pruning. Is there any option? Because
So we have best to catch up afterwards. We have a piece of software that allows you to prune. We have some ideas of what we're going to release, but this is not a really truly. It's not a question we have a really good answer for. There are some tools we have that you could use to prune your state. But there's ways we could improve, but if you need some details, catch me afterwards.
If all what you're saving on the public chain is the hash of the private transaction, in principle you could also put the hash of transactions made using a different protocol on the Quorum chain. So you could just plug in different protocols that have nothing to do with this Quorum.
So, that's the part where it's not that simple. You would physically be writing new code and modifying Go Ethereum client. But the answer is yes, you can. Right now, we created a bridge to the transaction manager of Tessera that writes particular thing. It doesn't have to be Tessera, the API, as long as you follow the API, could be whatever you want. The API is actually, the communication is using IPC on the same machine. Right? So, but yeah, absolutely, you could write whatever you want.
There won't be any forking on the major chain,
Yeah.
but there could be different variations of the protocol in the private side.
Yeah, and you talk about like this is going into experimental area. We know that this is possible to do, but we don't have anybody who tried to do this. But it would be another cool project to play around with to see where it goes. Yes, but the answer is yes. You can actually, on the other end, it does not have to be Tessera. It could be whatever you want.
Do you know anything about the MediLedger project on Quorum?
Which one?
Do you know anything about the MediLedger project on Quorum?
Is that the Healthcare Alliance?
Yeah, for the pharmaceutical.
Sounds familiar, and I don't know much, but I've heard of it. If it's the same as a...
Yeah, it's the Healthcare Distribution Alliance.
Yes, okay, so I've heard a little bit about it. This is kind of very interesting. So Quorum is an open source project. There's some users of it at JP Morgan, but most of it is done by other companies that suddenly find themselves that they need some kind of need for blockchain and they want to experiment with what's out there. So that's how people start on Quorum. So we actually don't know. They don't need to tell us. They don't need to report anything to us. It's an open source project. You just use it. So at some point, we sometimes find out, like everybody else does, by Googling things, and we'll like, oh, cool, somebody's using Quorum. And occasionally, people come in for support in case you need support. Make sure you come to our GitHub or to our Slack, and you will actually speak with our engineering team, and we'll help you. Usually, the reason you need support is that something's broken, something doesn't work. The explanation and documentation is not super clear, so that's how you would end up speaking to us. But Slack is manned by our support team, including me, so this is also how we find out. So that's the Synaptic stuff. We spoke with some of the engineers, but I really honestly don't know the details. So the Synaptic Healthcare Alliance is trying to create a system where they can exchange safely data between different healthcare ecosystem providers, and they're trying Quorum, but I don't know how far it went, and we found out ourselves, as I said, by Googling. Actually, I have a Google alert, and when I find it, I'm like, oh, cool. And there's quite a few companies, so we know Microsoft is building something with Ernst & Young, which is supposed to be like a rewards platform on Quorum, but I honestly, I can't tell you anything about it because I'm not at Microsoft, and I wouldn't know what they're building, but that's really cool. There was another company that's building voting systems on Quorum, like regular election systems on Quorum, which is, to me, that sounds incredible. But there's many users, and we wouldn't necessarily know each one of them. So I know that Synaptic Healthcare Alliance is doing something, but I don't know what it is. So we do have some of their users on our Slack, so we can. If you join our Slack, I can tell you speak to these people, and you'll actually be speaking to the core team that's supposedly working on this stuff. Go ahead.
Who's doing the voting on Quorum? Can you say?
Yes. I mean, I think this company is called Cubistry.
Cubistry?
Yeah. Again, just message me afterwards or catch me up afterwards, and I'll tell you. I don't know what they have in public, but this was on our Slack that the gentleman from this company was talking about what they're doing.
Are there any APIs to the transaction manager and the enclave if you want to build some?
Yeah, I mean, this is documented pretty well, so So again, this all sits on GitHub. We have quite a few repositories in here. This is Tessera, and the wiki is pretty complete. We update this, and so it has all the explanation, including the APIs and the interfaces and what we support. There's a Swagger doc that's a little bit richer, but it doesn't tell you which one is which server because the Tessera to Tessera is one layer and one server. Third party is another server. Quorum to Tessera is a IPC specific server. So, but this is well documented, or at least we think it's well documented. If you don't, we accept pull requests and contributions gladly. So.
Is there a ready-to-use DApp for cross-border payments?
The what?
Is there a ready-to-use DApp for cross-border payments?
No, not on Quorum. I mean, off the top of my head, there are some. It's not cross-border payments, but there is a good example that was built by Brazil's central bank when they were experimenting with Quorum. called 5-node RTGS, which is real-time gross settlement system. So it's a really good example of using a privacy system or privacy layer in Quorum, but it's not cross-border. And it's just an example for others to like learn and build things similar. Honestly, I can't think of one. All right. Okay. People didn't fall asleep, so this is always good. I brought some swag, so we have some stickers here, magnets, and a webcam cover. So feel free to take some before you leave. And if you have any questions or you want to talk afterwards, just come up to me, and we can catch up.